Good morning. Today is Thursday, May 21st, and we're going to talk about probability. The first probability that we're going to talk about is called theoretical probability. But let's go back. What is probability? Probability is the likelihood that some event will occur. It's also the chance that some event will occur. So I said the word theoretical probability. Theoretical probability is based on knowing all of the equally likely outcomes of an experiment. So you know what is going to happen. It is what is expected to happen. So if you flip a coin and you want to know what's your chance or the likelihood of getting a tails, well, that's a 50-50 chance. It's a 50% chance that you're going to get a tail if you flip a coin. Because and that is called a theoretical probability because you know what's going to happen. That's your percent chance of it happening. You don't actually have to flip a coin to know that there's only one side of the coin that's a tail and the other side's a head. All right. So the definition of probability that's in a textbook says the probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. And the way that you're going to see us writing probability is P stands for probability. Okay, so this P that I have in this box here, that stands for probability, and the event is what we're talking about. All right, so like the probability of a coin landing on the tail. So I could have wrote the probability of landing on a tail. Okay, and it says that's the number of favorable outcomes over the number of possible outcomes. So the number of possible outcomes is 2, right? There's a heads or a tails. And the number of favorable outcomes, well, I want a tail. There's only one side of the coin that's a tail out of the 2 possible sides. So that's why I get a 50% chance. Okay. So I have another basic example here using the coin. All right. So here's your penny. And if I wanted to figure out the heads, what's the probability of getting a head on a coin? Well, that's taking the number of favorable outcomes, which is 1. There's only one side of a coin that has a head out of the 2 possible outcomes. So the probability of getting a head is 1/2, which is 50%. Okay, so probability can be written as a fraction, a decimal, or as a percent. So I want to have you look at this diagram with me here. All right, so if something is impossible to happen, that you have a 0% chance of that happening. It's impossible. It's not going to happen. So that's the one end of the spectrum. The other end of the spectrum is the 100%. It's going to happen. You are 100% sure it's going to happen. All right. So if you get a probability, you're doing a problem and you get a probability where it's 25%, okay, that's unlikely to happen. Maybe the forecast is a 25% chance of rain today. Well, that's unlikely, but it still could happen. That's a 1 out of a 4, and it's 0.25, which is 25%. So if I go a little bit further here, as likely to happen as not, which means it's a 50-50% chance. It's 1/2 or 0.5. Okay. And then if it's likely to happen, it's about a 75% chance of it happening, which is 3/4 or 0.75. So this diagram might be very helpful, beneficial to come back and reference because there will be some questions where we're going to ask you to describe the likelihood of an event occurring. So for example, I have a bag of marbles. What is the probability that I'm going to pick a black marble out of this bag? Okay, out of this bag, there is 1, 2, 3, 4, 5, 6, 7 marbles, right? That's 7 total marbles. What is the probability of getting a black one? Well, there's 1, 2, 3, 4, 5, 6. All right. So 6/7, if you take a calculator and figure out what 6 divided by 7 is, that's about an 85.7% chance. Okay. That's 85.7. So it's probably going to fall in the likely category. Okay. So the likelihood that picking a black marble out of this bag of 6 black marbles and 7 total marbles is likely to happen. Okay. All right. So let's do the same thing with 2 other bags here. So the first one says picking a black marble is what? Is it certain, likely, unlikely, or impossible? So if I look at this first bag here, I have 1, 2, 3, 4, 5, 6, 7 total marbles, and I have 1 black marble. So the probability of getting a black marble here is 1 out of 7, which is about a 14% chance. So if you go back, we can go back to this diagram here. The 14% chance looks like it comes in the unlikely category. Okay, so 14% chance is unlikely to happen. So the probability of getting a black here is unlikely. Now let's look at the other one here. For each bag below, describe the likelihood of picking a black marble in the second bag. Well, we have 1, 2, 3, 4, 5, 6, 7 black marbles out of 7 total marbles. So that's a 100% chance. Our probability was a 7 out of 7, which is 1, which is also 100%. And that falls into the certain category. It is 100% certain that you're going to pick a black marble. Okay, so now let's find some probability, some basic theoretical probability. So suppose you roll a number cube. And when I talk about a number cube, I'm talking about a 6-sided cube that you would play in a game of Yahtzee or a game of whatever board game that you're playing. Okay. What is the probability that you roll an even number? Well, in a 6-sided number cube, the number of possible outcomes, there's 6. Well, how many favorable outcomes? When I say favorable, that's what you want to have happen. So I want an even number. Well, in your numbers, 1, 2, 3, 4, 5, 6, even numbers are the 2, the 4, and the 6. So that's the 3 out of 6. Okay. So the probability of getting an even number is 3 out of 6. We can't keep it as 3 out of 6. We always have to simplify our fractions. So if you leave it as 3 out of 6, you're not going to see the correct answer on your assignment. So we have to reduce that. That gives us 1/2 and change that to a percent because it makes a little bit more sense when you do change things to percents for some of these problems. So that's about a 50%. All right. So again, this P stands for probability. The even number, that's what you want to have happen. So the probability of getting an even number on this number cube is 3, because there's 3 even numbers, 2, 4, and 6, out of the 6 total possible outcomes. So I reduce the 3 6 to 1/2, and I change it to a percent, which is a 50%. And if you don't know how to change it to a percent, and if you have a calculator, you just take 1 and divide it by 2 in your calculator, and that will give you 0.5. And remember, to change decimals to percent, we just move your decimal point over 1 or over 2, and then that becomes the 50%. So again, you just take the numerator divided by your denominator in your calculator, and that gives you your decimal form. And to change your decimal to a percent, you move it over to the right 2 spaces. Okay, so let's do another one. So suppose that you roll a number cube. What is the probability that you roll a number greater than 1? Okay, so this is what my event is, the probability of a number greater than 1. Well, how many numbers are greater than 1? If you need to write down your numbers, you have 1, 2, 3, 4, 5, 6. Well, the 2, the 3, the 4, the 5, and the 6, which means that's 5 total numbers. Okay, the 5 total numbers out of the 6 total possible outcomes. Okay, and then if you take the 5 and divide it by the 6 in your calculator, 5 divided by 6, you'll get 0.8333, and it keeps going. So you just move it over twice, and so it's about an 83.3%. Okay. Let's do another one. So suppose you roll a number cube. What is the probability that you roll a 4 or a 5? Well, the probability of rolling a 4 or 5 is 2. There's two numbers that are a 4 or a 5 on your number cube, right? 1, 2, 3, 4, 5, 6. So if I want to roll a 4 or a 5, I want only two numbers to happen. That's my favorable outcomes. I only want 2 out of the 6 total numbers. So 2 out of 6, if you put that in your calculator, that gives us about a 33.3%. And don't forget, you have to reduce your fractions too. So 2 out of 6 is the same thing as saying 1/3, because you can take and divide a 2 out of both the numerator and the denominator. Okay. All right, here's another example. In a group of students, 12 students ride the bus to school. Okay, 12 students ride the bus. 8 students are driven to school and 5 students walk to school. One of the students is chosen at random from the group. What is the probability that the student will walk to school? Well, what is the total number of students? I have 12 plus 8 plus 5. That gives me a total of 25, right? And then it says, what is the probability that the student will walk? Well, how many students walk to school? Well, that's 5. That's my favorable outcome out of my total of 25. Okay, that can be reduced because I can take and divide both the top and the numerator and the denominator by 5. So I get a 1 out of 5 chance. Okay. So I have this here. So the probability of getting a walker is 5 out of 25, like we just did, but that can be reduced to 1/5. And if you take that into your calculator, 1 divided by 5 gives you a 0.2, but you move that over twice, and that will give you a 20%. So the probability that the student will walk to school out of the group of those 25 students would be a 20%. Okay. So here's another example. I have a spinner. It has 10 equally sized slices shown below. They're all equally likely to be spun. So the dial is spun and it stops on a slice at random. What is the probability that it will stop on a gray slice? So we do have 3 different colors here. We have the black, the white, and the gray. So my gray here are these 2 out of how many total? Well, the total number of slices is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 2 out of 10 slices that are gray. Is that simplified? No, we have to simplify that to 1/5, which we just had 1/5, which is a 20% chance. So if this was a spinner in a game and you wanted to land on a gray slice, you have a 20% chance of landing on that gray slice. Okay. Now, those are basic probability questions. And what happens if I said, well, I didn't want to land on that gray slice and that question that we just did? Those are complementary events. Complementary events are 2 events in which either one or the other must happen, but they can't happen at the same time. So an example, you have a coin. A coin can either land on a heads or not land on a heads. You can't land on a heads and the tails at the same time. So you have a 50% chance of landing on your head and a 50% chance of landing on the tail of the coin. Okay. You can't land on the same thing or you can't land on both of them at the same time. So those are complementary events. So you have 50% chance of landing on your head, 50% chance of not landing on your head. So the sum of the probability of an event and its complement is 1 or 100%. So when I go through some examples, this will make a little bit more sense. So find the probability of not rolling a 6. So again, think about your number cube. You have 6 total numbers. How many are not a 6? Well, I have 1, 2, 3, 4, 5. So the probability of not rolling a 6 is 5 out of 6, which is about an 83.3%. And the probability of rolling a 6 should be 1/6. So those are the complementary events. So the probability of rolling a 6 is 1/6. So as you can see, you have 5/6 and 1/6. And if you add those two together, you'll get 6/6, which is 1 whole. Those are complementary events. Okay, let's try another example. Here's a bag of marbles. There's 5 blue marbles, 8 red marbles, and 7 green marbles. Technically, that bag does not have 5 blue, 8 red, and 7 green. So don't look at the picture, but the picture that I found has those colors in there. Okay, so a marble is selected at random. Find the probability that it is not red. Well, how many total marbles do I have here? Well, I have 20 total marbles. All right, so you have 5 blue, 8 red, and 7 green. That gives you your total of 20. So that's your denominator there. So why do I have 12 as my numerator? Well, I have 12 as my numerator because I want the ones that are not red, which means that's the blue and the green. And 5 plus 7 gives me the 12. Okay, so 12 out of 20. Am I done with that probability question? No, because I can reduce that. I can reduce that to 3/5 because I can take and divide both the numerator and denominator by a 4. Sorry, I'm writing's a little sloppy there. So 12 divided by 4 is 3, and 20 divided by 4 is 5. And if you put that in your calculator, that's about a 60% chance, which is pretty likely to happen. Okay, so you have a 60% chance of grabbing not a red marble. So you have a 60% chance of grabbing either a blue or a green marble from that bag of marbles. Okay, so be very careful when the question is asking the not. Be very careful. Sometimes it might be bolded, underlined, italicized. Sometimes it won't. And our eyes play tricks on us and we won't be able to see that it won't stand out to us. Okay, so make sure you read your questions word for word and so you don't miss that. All right, so here's another one. So a spinner is divided into 8 equal sections, numbered 1 through 8. So here's my spinner, 1 through 8. What is the probability of not spinning a 5? Like I just said, I don't have that not bolded or underlined or highlighted or anything or circled. But if you didn't read that question, you kind of skimmed over it, you saw spinning a 5. If you didn't see not spinning a 5, you would get the opposite answer. So what is the probability of not spinning a 5? Well, there's 8 sections on this spinner, and not spinning a 5, well, there's 7 of them, right? The 7 that are not a 5 is the 1, the 2, the 3, the 4, the 6, the 7, the 8. There's 7 out of the 8 that's not a 5. Can I simplify that anymore? No. Okay. So my probability is 7/8, which is an 87.5%, which is likely to happen. Okay. So Mr. Haranda surveyed his class and discovered that 30% of his students have blue eyes. So identify the complement of this event and then find its probability. Well, if 30% have blue eyes, the complement is what is the probability of not having blue eyes? Then we could say, well, the probability of not having blue eyes could be the probability of having green eyes, hazel eyes, brown eyes, okay, which is not blue eyes. And so if the probability of having blue eyes is 30%, then the opposite of that is 70%. And how did I get that? Is I took 100% minus the 30%, and that gives us the complement of 70%. So if you're given just the percentage and it's asking you to find its complement, you take that away from 100% because the 2%, the complement and the not the complement will add up to be 100%. So again, if it's asking you to find the probability of a complement given the percentage already, take that percentage away from 100%. So 100% minus the 30% that was given to us gives us the 70% complement. All right, so a few checkpoint exercises here. So an algebra class has 17 boys and 16 girls. One student is chosen at random from the class. What is the probability P that the student is a girl? So the probability, that's the P, that the student is a girl, there's 16 girls out of the 33 total. Can we reduce that? No. But if you put that into your calculator, that's 16 divided by 33, and that gives you a 0.485 in your calculator, and you move it over twice, and that gives you the 48.5%. All right, let's do one more. So a sportscaster predicted that the Tigers have a 75% chance of winning tonight. Identify the complement of this event and then find its probability. Well, if the Tigers have a 75% chance of winning, the complement would be losing, right? The opposite of winning is losing. So the probability of losing is 25%. And how did I get the 25%? Well, if it's a 75% chance of winning, there's 25% chance of losing because those would add up to be 100%. Or you could just take 100% minus the 25%, and that gives you that 75%, the complement to the 75%. All right. If you need to go back and watch this video again at some certain points, make sure you go back and rewatch this. Make sure you email your teachers and ask for any help if needed. Office hours are every day from 11 to 11:30. The post will be posted up there. The link will be posted around 10:55 in the morning. And have fun with this.